Hi, welcome to lesson 27, session 1. Today we're going to be learning all about making line plots and interpreting data or data. I'm going to probably say it both ways, so just get used to it. We'll stick with data unless I forget and say data. We will be working in our Ready Classroom math workbook. We'll be on pages 553 through 556. I am going to go over a couple of concepts before we get to the math, but you can go ahead, take out your Ready Classroom math workbook and go to page 553 now, and then just hang on 1 second while you go through a little bit of extra information with me. Okay, so I'm going to get here in just a minute. I want to go ahead and go over a couple of things that you're going to need to know as we go throughout this time with making line plots. I really want you to think about benchmark fractions and what we know about benchmark fractions. So benchmark fractions are fractions that we know, we've talked about them before, but they're fractions that we know that are kind of common that you can almost always kind of revert to. Like if I told you I have a half of a pound, you would know that a half is halfway between 0 and 1. Or if I told you a quarter of a pound, you'd likely know that a quarter was somewhere around this spot here, and then 3/4 would be almost all the way to the end, but not quite. So typically our benchmark fractions are anything that are really a multiple of 2. That's mostly what we'll be talking about over the next little while. So we also can see, you can't really tell this is color coded, but it's a little hard to see. We have this number line is going from 0 to 1. We've broken it in half. We've also broken it into quarters. And finally, we've broken it into eighths. Now, just because this 1/2 is here, this 1/2 is also the same as 4/8 or 2/4. 1/4 is also the same as 2/8, 3/4 as 6/8, and then 1/2 is the same as 8/8, 4/4, and 2/2. So all of these are just equivalent fractions. And so if somebody told you that they had that the value was 3/4, you would mark the value as being at 3/4. If they told you the value was 6/8, you would also mark the value here because 6/8 is between 5/8 and 7/8, and it is equivalent to 3/4. So I just kind of wanted to give you that little bit of a way to look at it so that you can think about those benchmark fractions and the fractions that are equivalent. Along that line, I wanted to show you this number line, these fraction number lines, and so that you could kind of see what those equivalent fractions are. So 1/2 is equivalent to 2/4, 3/6, 4/8, 5/10, and 6/12. Then if we had 1/3, 1/3 is also the same as saying 2/6 or 3/9, and so on and so forth. And so if you are ever struggling to try and figure out what the equivalent fraction is, you're looking, if you had a ruler, let me see if I can grab one here. If you had a ruler, if you line up all of these yellows, as you can see, go straight in a line. So all of these would be equivalent to 1/2. If you were looking at thirds, all of these are equivalent to 1/3. All these thirds are equivalent to 2/3. If you're looking at 3/4, 3/4 is the same as 6/8 and 9/12. If we were looking at fifths, which we rarely do, but if we were looking at fifths, 2/5 would be equivalent to 4/10. So if you would like one of these, you can ask your teacher to have one. If you're in my class, you'll be getting one at the beginning of this lesson, and we'll even highlight it and as much as we can, make it beautiful. And I would say that for the majority of what we're doing over the next month, next week, we'll be working in halves, fourths, and eighths. Those are going to be the numbers that we're most often dealing with. So you're really only going to be using, I'll put a little star here. We'll be using halves, fourths, and eighths for the most part. If you want, you can pause this video here and take a screenshot if you do not have this benchmark fraction page. All right, with that, we're going to go ahead and get started on the lesson. As I promised, we're on lesson 27, session 1, on page 553 in our Ready Classroom Math Workbook. You have made and used line plots before. Now you will make line plots and use them to answer more complex questions about data. Use what you know to try and solve the problem below. So let's go ahead and read the problem. It says, Mrs. May's class weighs tomatoes of different sizes and types. They weigh each tomato to the nearest 1/8 of a pound. The results are shown in the line plot below. What is the difference between the weights of the heaviest tomato and the lightest tomato? So first of all, we're going to go ahead and figure out, what is this problem talking about? In this problem, what's nice is when we have a line plot, the line plot usually has a title. The title tells us what the problem is about. So we are talking about the weight of tomatoes in this problem. Then we need to find out, what is this question asking us to do? What is it that we need to solve? And what we need to solve is, what is the difference between the weights of the heaviest tomato and the lightest tomato? And then finally, what is the important information in this line, in this math problem? So it says Mrs. May's class weighs tomatoes of different sizes and types. They weigh each tomato to the nearest 1/8 of a pound. The results are shown in the line plot below. What is the difference between the weights of the heaviest tomato and the lightest tomato? So believe it or not, this is in the actual problem. This is the only important piece of information that we need to know. And then I'm going to put a giant star. I don't know if you can see that, but a giant star next to this table, because this table is actually part of the problem. And this is the other important information that we need to solve this problem. So right now, I want you to go ahead and pause the video, and I want you to figure out, what do you think is the difference in the weights of the heaviest tomato and the lightest tomato? I want you to go ahead and try your best, see what you come up with, and then come back to me. Okay, I hope that you paused the video and you went and tried to figure this out on your own, so that you can just listen to what I do and see if you did it the same way. Maybe you did it a different way. So if it were me, the first thing I'm going to do is, I'm going to use this 1/8 of a pound to help me out. Since I know that each tomato is the nearest 1/8 of a pound, I know that that probably tells me what the scale of my line plot is going to be. Meaning, what is the difference between each of these tick marks on our number line? Now, if we don't know, we can actually count how many tick marks we have, and that's going to actually tell us what the value is of each tick mark. So we do not count the 0, but we do count the 1. So let's count our tick marks, starting at the tick mark after the 0. We have 1, 2, 3, 4, 5, 6, 7, 8. So that means that the scale of this line plot is 1/8, because the difference from each tick mark to the next tick mark is 1/8. Now, this 1/4 doesn't say 1/8, but it still is it's 1/8 more than 1/8. So if we look at our benchmark fractions, that form I showed you earlier, we know that 1/8 really is next to 1/4. How does that make sense? That's right. 1/4 is an equivalent fraction to 1/4 is 2/8. So we can still, this would be the same as 2/8. Up here would be 3/8. 1/2 would be 4/8. This would be 5/8. 3/4 is 6/8. We would have 7/8, and then 1 whole is 8/8. So we have all of our 8s going across. Now, I wouldn't call 1/4 2/8, 1/2 4/8, or 3/4 6/8. That's not necessary at this point. Or is it? You'll see. Okay, So now we've labeled our line plot. We know that the scale from one tick mark to the next tick mark is 1/8 of a pound in this case. 1/8 of a pound, but the scale is 1/8, meaning there's 1/8 between from here to here, 1/8 from here to here, 1/8 from here to here, all the way across. Now let's go back to what the original question is. What is the difference between the weights of the heaviest tomato and the lightest tomato? Well, the heaviest tomato is going to be the tomato that weighs the most. This number line shows the amounts from least to greatest. So and all of these X marks show us all of the different weights of the tomatoes. So which tomato weighs the most? That's right. The tomato that weighs the most is right here. This amount right here. So we know that this tomato that weighs the most weighs 3/4 of a pound. So we're going to take the tomato that weighs the most, which is 3/4 of a pound, and we're going to subtract the tomato that weighs the least because we want to know the difference between the heaviest and the lightest. So this would be, instead of most, I'm going to write heaviest. And then I'll fix that down here as well. I like using the same terminology that they use in the text. So sometimes I will change my mind mid question, and that's okay. So we're going to call this the heaviest, and this one the lightest. So if we're looking, and if this side is where we have the heaviest tomatoes, and this side is where we have the lightest tomato, what is the lightest tomato that we have? Well, it's a good thing that we labeled that mark because the lightest tomato, there's many of them, but they all weigh 1/8 of a pound. So we're going to subtract the 1/8 of a pound, and that's going to give us our answer. So if I'm subtracting fractions, can I subtract 1/8 from 3/4? No, I can't. Don't forget, you cannot subtract fractions unless they have a common denominator. So we need to make it so that both 3/4 and 1/8, we're going to find equivalent fractions to make them have a common denominator. Now, you might already recognize something that can help us out. What is it? Go ahead and just tell me. I know I can't hear you, but just tell me anyway. That's right. We wrote that 3/4 is equivalent to 6/8 up here. So we know that we can rewrite 3/4 as 6/8. And then we can subtract 1/8. Now, can we subtract 1/8 from 6/8? Yes, we can, because we have equivalent and we have the same denominator. So remember that our denominator stays the same and we just subtract the numerators. So 6 minus 1 is 5. So the difference in weights is 5/8 of a pound. So when we're trying to find the difference between, oh, I forgot to circle up here that this is the lightest. So the difference between the heaviest tomato and the lightest tomato is 5/8 of a pound. Let's go ahead and go to page 554. All right, on page 554, it says, look back. And then it says, what is the difference between the weights of the heaviest tomato and the lightest tomato? Explain how you know. Well, since we just did it, I'm just going to go ahead and show you a brief synopsis of what we just wrote. So it says this: we know the difference is 5/8 of a pound. We know that the heaviest tomato was 3/4 of a pound and the lightest tomato was 1/8 of a pound. If we subtracted 1/8 from 3/4, we knew we couldn't do that, but we could find an equivalent fraction to 3/4 that was 6/8, and we could subtract 1/8 from 6/8 because they both had the same denominator. And when we did that, we got the final difference of 5/8 of a pound. Now, looking ahead, we can graph data. I had to remind myself to say data and not data. We can graph data on a line plot and to help you get a picture of the data and how the data are spread out or grouped. So when we're looking at the tomato weights, we know that this is looking at tomato weights because that is the title of the line plot. We also labeled the line plot with weight in pounds so that we would know the unit of what each of these X's represents. And then we know that we can look at these tick marks and use our benchmark fractions that we know to figure out the values of each of these data points. That's what these X's are called, data points. So the scale of a line plot is the value represented by the distance between one tick mark and the next on the number line. So remember that I talked about the scale is the distance from one tick mark to the next tick mark. How much is in between? Now remember, we figured out that this was 1/8, this was 3/8, this was 5/8, and this was 7/8. I always like to fill in all the tick marks. I know that not everybody uses that strategy, but I feel that when I write in all of the amounts on the tick marks, that it just makes it a little bit easier for my brain to manage. The other thing, if it's easier for you, you can also write in those equivalent fractions at the same time so that you go in order. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. It's not necessary to write that all in, but for some reason, my brain just it makes way more sense when I write in those equivalent fractions on those other benchmark fractions, so that if I'm having to do any work where maybe I add them all together, all of these values together, or I am going to subtract, it just is easier to have all the same denominators. Now, the scale, so as I was mentioning, I got off on a little tangent there. The scale of the line plot is the distance from one tick mark to the next. So we're trying to figure out what is the amount between each of these tick marks. So we know that from this tick mark to this tick mark, they first ask us, counting up, how many tick marks does it take to get from 0 to 1? Remember, we don't count the 0, we start here, and we have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 tick marks. Now, what fraction of the whole is the distance between tick marks? We know that each of these sections is 1/8 of the whole. So the scale, so 1/8 of a whole is how the length of this yellow space here. This is 1/8. And then from here to here is 1/8. From 1/4 to 3/8 is another 1/8, and so on and so forth. So we would call the scale of this number line 1/8 of a pound. So if anybody ever asks what is the scale of this number of a number line, you're looking at what is the distance from one tick mark to the next. That is the scale of the number line. Now, for part B, it says how many data values are recorded on the line plot. Remember that I said that all the X's are the data. See, I said data. All the X's are the data values or the data points. So, how many X's do we have all together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So, we have 14 X's, so there are 14 data values on the line plot. And then finally, part C says this. What do the four X's above 1/8 represent? The X's tell us that 4 tomatoes weighed 1/8 of a pound. So we know that each of these X's represents a tomato that weighs 1/8 of a pound. Now, if the scale on the line plot is 1/8, which we know it is, that's the scale, then why are the numbers 1/4, 1/2, and 3/4 and 1 on the line plot? So why did they use 0, 1/4, 1/2, 3/4, and 1? Well, 1/4, 1/2, 3/4, and 1 are all equivalent fractions to, so 1/4 is the same as 2/8, 1/2 is the same as 4/8, 3/4 is the same as 6/8, and 1 whole is the same as 8/8. So we know that even though they're written as a fourth, a half, 3/4, and a whole, that really, that the reason that we can write them that way is because we've just written them as equivalent fractions to the value that has an 8th. Once you've got that written down, we're going to go ahead and fill out our graphic organizer on page 555. So we learned, we talked about 3 different vocabulary words in this lesson, and they really are words that we need to understand for the next few days. So a line plot is a graph that uses X's above a number line to show data. So an example of a line plot would be numbering the line plot from 0 to 1. And then I labeled mine 1/4, 1/2, and 3/4. And then the X's above above the number line are the data points that show us how many of that value that we have. The scale is the change in value between one tick mark and the next on a line plot. So if I looked at the scale of this line that I drew, we're talking about what is the distance between one tick mark and the next tick mark. And in this case, if the distance from 0 to the first tick mark is 1/4. So this line plot has a scale of 1/4. Data are information of facts. So the data in my line plot shows that I have 2 values at 1/4. I have 3 values at 1/2, and I have 1 value at 1 whole. So the data in my plot is 1/4, 1/4, 1/2, 1/2, 1/2, and 1 whole. You're going to go ahead and do numbers 2, 3, and 4 on your own on the rest of these 2 pages. If you have any questions, you can always email your teacher. Otherwise, I'll see you next time.